So we looked at an inertial frame, so a frame that's just moving at a constant velocity. Now let's look at one that's accelerating. Okay, so imagine, we have a person sitting in a car. Okay, and so when this person's driving the car, let's look at all the forces that are in place. So again, this would be the rest frame. So in the rest frame, if you're sitting outside the car, well, you would see gravity pulling down. You would see the car accelerating. And so, of course, we know that there's really a frictional force on the tires, and that's pushing the rest of the car. And in the end, we have the seat that's being pushed. And so the seat on the person is, pushing with some normal force. Well, we'll just call it F, the seat, the forward velocity that it's being pushed with. But then we also do have a normal force from the bottom of the seat pushing back up on the person. Okay, and we know that we have a net acceleration that's going to be in the x direction, right? So in this frame, we see that the mass times the acceleration is going to be the normal force minus the gravitational force in the y direction, and then the force F in the x direction. And this is just going to be equal to the mass of the person times his or her acceleration, right? And so we know that in general, well, actually, we won't do that quite yet. Now we'll go and we'll look at the same picture, but now we're going to be in the rest frame. So now let's say we're actually this person sitting on the car. Okay? So now this is us, and now we look at all the forces on us. We say, well, we have a force of gravity pushing down on us. We have a normal force pushing up on us. We still have a force of the seat pushing to the right. But if you think about it, think about when you're at rest at a stop sign, and imagine you step on the gas and you accelerate really fast. Okay, when you do that, you're going to feel yourself being pushed back into the seat, right? You've probably driven with a friend before, done this yourself, where you accelerate really fast and you feel yourself like pushed back in the seat. So we feel another force pushing us back. Okay, we'll call it FFC for now. Okay, the reason we need this force is because in our frame, everything here is stationary. Okay, so if we have this force F pushing us to the right, in order to keep us, in the same, not moving to the right with respect to the seat and everything else, we have to have some other force pushing us back. Okay, so this is the force that balances us and keeps us at rest. But let's look how we would write our acceleration or our net force. As if we looked at it in the first place. What we were really looking at is we said this is F1 plus F2 plus F3, plus all the forces that are acting on us, right? But then, if we go back and look at our transformations, we said that in our frame, our movement would seem to be A prime, which is our initial acceleration, which is the acceleration outside the frame minus the acceleration of the frame, which means our actual acceleration to somebody in the rest frame is equal to the acceleration in our frame plus the acceleration of the frame. So if we take this and we plug this back in for this acceleration, we see that we have our mass, our acceleration in the frame times the acceleration of the frame. This is going to be equal to F1 plus F2 plus F3 and all the other forces acting on us. So now, just moving this term to the other side, we see that we have mass times acceleration is minus the acceleration of the frame times our mass plus F1 plus F2 plus F3 and all of the other terms. So now we look at this term here, this minus acceleration of the frame m. This is our force, our frame correction force, this FFC up here. We see this is where it comes from. When we switch to this non-inertial frame, right? This is a non-inertial frame. Now we have this fictitious force. This isn't real, right? We know it's not real because if we're actually looking at this from outside of our frame, we see that there's really only 3 forces acting on us. But in switching to a new non-inertial frame, right, the frame of the accelerating car, all of a sudden there's a new force that comes up that has an acceleration opposite to the acceleration of the frame. Okay, so this is kind of how you would rework Newton's laws if you are in an accelerating frame.